Okay, cool. So awesome. Yeah. So thank you so much. This is really great to have everybody here. I'm going to go ahead and share my screen and we'll start a little bit of the lecture. So first off, just a little bit about this class. So this is actually the first time we're teaching this class. So I'm actually really excited to sort of see what works and what doesn't. There will be many things that probably won't go over very well, or like just won't be as interesting and exciting. So we'll fix that for next time. But really happy to have everyone here. And your feedback is super welcome. So if you are like, this isn't what I expected, or like, I'm not getting what I need out of this class, please let Lia or I know. It's 3 weeks. We only have a couple weeks to really adjust our schedule, but hopefully we can do that. So, in the case of someone like Esteban, I think, this week might be a little bit more scraping focused, but I promise we'll get to some other data set generation sort of tips and tricks that we can do in the later classes. So yeah, this class is going to be really quick. We're going to dive through a lot of stuff, but just know that you're welcome to give us feedback as quickly as you want, even in this class itself. So there's a couple of objectives. If you've taken any of Lia or I classes before, you'll know that like the big thing that we want to stress in this class is that it's about learning through making. So there are lots of classes where like they teach you about machine learning and then you never actually get to make anything. And in this class, we want to sort of like, we want to do the opposite. We want you to learn by making stuff. So in this class, like you're going to be scraping data, collecting images, doing manipulations of those images, and learning about like data sets by doing that work. I personally find that you just learn a lot more that way, especially if you are someone who wants to make stuff out of this and not just learn how it works. This sort of gets you on your way, and then also Lia and I are here to support you through that process. So if you get stuck somewhere, you DM Lia or I, or you DM the Slack channel, or you show up for our office hours, and we actually will sit down and walk through things with you. So hopefully this is a way for you to get some hands-on experience, but also to learn from two people who are also doing this pretty frequently. So today's class will actually mostly be about sort of just level setting for everybody and talking about models and how data like influences models. But we'll talk a little bit about that. So like we'll go over all the various models and the type of different data inputs that they take. Mostly focused around images, but maybe a little bit of video stuff as well. And then the last thing, of course, is we really want people to learn a little bit about how to manipulate and manage data sets. So the next 2 weeks of classes will really be like, okay, if I have a small amount of data, how do I increase the number or like the number of images I have? If I have messy data, how do I clean that up? Or how do I begin to categorize and sequence things in a way that might work better for the models that I'm looking at? So a lot of this is going to be exploring like individual ways of manipulating data and potentially at scale, right? Because it's easy to open up an image or two in Photoshop and crop them. It's much harder when you have 1,000 images. You don't want to be using Photoshop for that, right? So we're going to look at some techniques and tools and libraries and a little bit of code. This isn't like a coding class, so it'll just be a little bit of like pre-built tools that you can use, but you might have to get into the command line a little bit. So we're happy to walk people through the command line if you are a command line newbie and or if you're scared. I know when I first started, I was very scared of the command line, and now it's pretty much my like preferred tool. So we'll get people up to speed if that's not really your thing. So the schedule for this week, for the next 3 weeks, as I mentioned, this week will really be about like just sort of data sets and models and sort of just getting everyone to understand like sort of our approach to these things. And then Lia is going to do a little bit on scraping ethics, which I'm really excited about. Week 2 will be really about like, so we'll look at how to do web scraping, which is just like we'll be using Beautiful Soup. So if you're interested in that technique, I'll be doing a demo of that. And then we'll mostly be talking about what I call augmentations. Augmentations are cropping, scaling, rotating, any number of things you can do with data. So we'll look at a library that I've been building in the side for the past year or two called Dataset Tools, and we'll look at how to use that. We'll also probably look at some things that maybe like tying it to like Adobe Photoshop tools or like other tools that you can use to do some of this work sort of automated inside of Adobe tools. And then week 3, I think we're going to look at classifiers and detectors. I'll talk a little bit more about that. We'll also look at some more advanced augmentation techniques. Like if you are low in terms of how many images you have or you need for a data set, we'll look at how to like update those. So like a lot to cover in 3 weeks, but I think we can get through it. And I think we can add to this as people are interested in other topics. We can cover some new things as well. As a part of your course, you do get sort of a 20 to 30 minute one-on-one with Lia or I. We'll post our links to our Calendlies probably next week. So you can just sign up for a session to work with one of us on a particular project you have or something you're working on, or just ask us questions. And so we'll put that link out. I generally recommend it's best if people come with questions. We can hang out and just talk for 20 minutes if you want to, but it's usually easier if people have questions that they want to come, or like a project they're working on that they need help with. So just be aware of that. And those are, you can schedule that whenever you want. So like, doesn't have to be within the next 3 weeks. It can be a month after class is over, whatever. Although I do generally find that if you do it a week or two after class, you'll at least remember and have things to talk about. Otherwise, some people will schedule them a month out and then like a month comes by and they're like, I haven't worked on anything, so I don't really have anything to ask you about. So just, use that time because you did pay for it. So this class is actually fairly heavy on homework if you choose to get really, really invested in it, in part because we're going to look at like setting up a lot of different models, and pulling down data requires a lot of effort, and it is manual process no matter what. There is always some manual level of data set work. So on the short end, if you just want to do like the most basic things and maybe just want to like hang out and sort of learn, you're looking at maybe 2 hours of homework. If you want to get really, really invested and make a lot of data sets and do a lot of scraping and cleanup and that sort of thing, you could be talking 8 to 12 hours of work each week. Pretty easy to like, especially when we get into like stuff like tagging data, that can take you a long time. So I'll show some tools we have that can make things a little bit quicker, but just know that you could be in for a big experience. Again, this is flexible, and obviously depending on what you're interested in, or depending on what you have going on outside of work. I know lots of us have families with kids at home these days. We can always modify this. So there's no expectation that you do all the homework, right? It's just generally it will help you learn more if you do more of the homework, and you'll come in with more questions. So, this is sort of what we expect, a couple hours of work just to sort of like stay up to pace and like have lots of questions each week. But I know some of you are really excited about this and will probably invest a lot of time and effort into this work. So just be aware that's sort of what we're thinking for each of these classes. And based on what we sort of assign, or like what we tell you to work on. Some materials for these classes. The number one place to look is the class site, which is linked to both here and from Slack. The class site will contain all of the slides for each lecture each week, as well as the video recordings from these weeks. So definitely recommend you check out that, that link. Yeah, so that's probably the number one place to look for everything. Next is Slack. So I do recommend that you try to use our Slack channel if you can. That's where we'll post a lot of updates and other things, and we'll basically like let people know when the class site is updated there as well. So that's probably a good place for you to go and share work and get feedback from other folks as well. Really quickly, I also want to point out that in our Slack channel, so if you're not already in the Make Datasets Slack channel, please let Lia or I know, and we'll make sure that we add you to this channel. I think everyone's already in there, but if you aren't, let me know and we'll make sure you get in there. There are many other public channels within the Slack channel. General is where like all the links and videos that go public on YouTube get linked to, so you can check them out there. The other place I'd probably recommend for this class is there's a datasets channel. People will generally post links to datasets or other things that are interesting if anyone's interested. And then lastly, I want to also talk about share projects, which is a place where if you're making cool things, you should feel free to share them there. Lots of people are really excited to see what other people make. So I would say those 3 channels are probably your best public channels to go to, but there's tons of other ones if you want to like dig around and see what's what. All right. See, keep it moving. Oh yeah, so okay. So classes, these classes will be mostly about lectures and discussions. They will mostly be us doing lectures as a way to sort of like help you like think about these things. A lot of times we won't do live demos because live demos have a tendency to not go well, and then we end up like wasting lots of time. Because we have a pretty compressed class, we want to make sure that we cover the things you need to think about. And then if you are interested in the topic, you can follow a demo video. So all these courses will be supplemented with videos that are on my public YouTube page. So every hour and a half of class that we have is actually maybe 3 hours of full video. So just be aware of that. And these videos are hopefully they're hopefully pretty self-explanatory, and they can walk you through the demo process of using things. If you do run into issues, please let Lia or I know. We're happy to walk through things or figure out where issues are, and we can also then update them as needed. So just be aware that there are additional videos that we'll be linking to for a lot of these classes. And then working sessions, there's a poll here that Lia put together. Please fill it out this week. Basically, when people like tell us what times they're available, we'll set up like a hour or two working session. Those working sessions are optional for people if they want to show up and have questions. That way they can sort of say like, oh, you know, I was stuck here. Can I get help with this sort of thing? So we'll basically find the time that works best for everyone when we can. And obviously, since we have a big international group here, we might have to be flexible in that, but we'll do what we can. Maybe Leah, you and I can talk about like maybe we'll split it up like an hour or something to work for everybody's schedule. Yeah, so those are optional. No one has to show up. One thing that Leah and I will do is we'll generally like the day before or the day of, we'll just make an announcement like, hey, working session is today from 5 to 6. And we'll ask that people like add an emoji or just add a comment there to let us know that people are showing up, because if it's a nice fall afternoon and no one has questions, we might want to go outside and hang out. So just be aware that like, please let us know if you're going to attend those sessions. That way we aren't stuck hanging around waiting for people to show up. Okay, all right. So one more thing to note in this class is that we won't be going over how to actually train your models. So this is really a class about data sets. However, if you are interested in, maybe you saw me talking about a model and you want to build a data set for that, and then you want to go ahead and train it yourself, we probably have videos about how to train that stuff, either on Runway or in a Colab notebook or on a server. So if you are interested in training something in particular, please let Leah or I know, and we can link you to resources for those things. Probably have videos recorded of them based on previous classes. We probably have a notebook that shows you how to do it in Colab or any other thing. And I know many of you are signed up for the StyleGAN class. So in the StyleGAN class, we'll definitely be going deeper into training StyleGAN models. But if you see another model that isn't a StyleGAN model and you're interested in sort of learning about training on it, please let us know and we can send you that way. Okay, we are already at 40 minutes in, so I'm going to keep it moving along, but please let us know if you have questions about any of this. So today we've already done housekeeping and intros, although Leah and I have a very short intro to do as well. And then we're going to do a lecture just on about like why data sets. Many of us probably already know why we're here, but I'll just point out a couple other things. Then we will take a break. We usually do about 5-minute breaks just so people can stand up, stretch, get some water, go to the bathroom, that sort of thing. And then we have a bunch of lectures and maybe a demo. We have a video demo, so we'll sort of see what we do with time-wise, where we are with things. But yeah, so any questions? All right, quick intros for me. Many of you have probably seen my artwork before. I'm a web designer by day. I work at MailChimp, which is why all of your Zoom links are MailChimp Zoom links during the day. And at night, I'm an artist and a web developer doing like this sort of work. I believe Owen mentioned that he learned from Gene Kogan. I also learned from many of these fabulous people at a place called SFPC. I similarly took like an intensive sort of like course from many of these people. And if you're not familiar with their names, I definitely recommend looking them up. Took a very intense course from them. And afterwards I was sort of brain dead and realized I needed to sit down and really study this stuff. And basically these classes, as well as many of the videos that I record, came out of me realizing that like none of this stuff is very well documented. It's all very hard to understand. And my hope is that like through these classes and videos, you can like, it makes it a little bit easier. You know, I'm not going to say it's easy to like understand a lot of this stuff, but it makes it a little bit easier. So yeah, so here are a couple of data sets that I work with pretty frequently. You maybe have seen them in my work. I work with a lot of floral images that come from a archive called the Biodiversity Heritage Library. We'll probably show a little bit of stuff over the next couple weeks from there. I built this data set by hand, taking a bunch of images and cropping into them really closely. And this sort of has become a go-to data set for a lot of things for me. So I've taken this data set and trained it in StyleGAN, which is what you see here. I've also applied it to a Pix-to-Pix or CycleGAN model and have generated faces using these like floral textures. So one of the nice things about data sets is they are reusable. You can find different ways to mold them and combine them with other data sets to produce new works. And then I'm currently really interested in fluffy cats. So a lot of our demos won't involve fluffy cats. This is a model that I just built last week, or trained on just last week, on doing object detection, which will come up in, I believe, our week 3 of class. So we'll be looking at lots of cats. So if you're a dog person, I apologize. We can train a dog model too if someone's really interested in that.
Yeah, and as for me, so yeah, I started doing machine learning from like first was doing it in industry as like training models for like classifying harmful content, and then was doing a little bit of research on machine generated artwork. This was a DC GAN model, which was trained on a data set called WikiArt, which is a publicly available data set of like 80K different pieces of artwork from different like eras or art movements. And that was in 2019. Next. And then after that, yeah, I went to SFPC, which is sort of like the connector bridge between Derrick and I last fall. And next slide. Oh, yeah, and this is some of my recent work. This was trained on a videos of flowers blooming, like these 4K videos of flowers like slowly opening that I scraped from YouTube and then split into frames. And this is just a StyleGAN2 model of that. And yeah, this is a next frame prediction model on the beginning of an Adult Swim episode, an Adult Swim off the air episode where, yeah, it's just a model that tries to predict the next frame. And the input to this type of model is just a video. So the data set for that one itself is not too hard to compile.
Cool. Thanks, Leah. Okay, so we're going to start our lectures. I'll cover this stuff fairly quickly, and then we'll take a break. So thank you for being with us for a minute. So why data sets? The reason I'm really excited about this class is two reasons. One is I find in the couple of years that I've been doing machine learning art, I find that like data sets are actually the real most creative part of machine learning art. So if you come from a world that is more like generative art focused, you might be used to like writing code, right, to generate images. And that works well in the generative art community where you're saying, I want a circle here, or I want to draw a line here, that sort of thing. In machine learning, many of these machine learning models are very complicated and have taken a long time for a team of researchers to build. So you are less likely to be messing with the code of those models and more likely to be adopting their models and adding your own data sets and doing your own training or your own work on that. So out of that, I really find that like the way to use these models is to create a really cool data set. So for me, that's like why this class is really great. The second part is that data sets are also like the hardest thing to produce. If you've done any data set production, either in my runway class or other things, you know it's very, very time consuming. And it can feel monotonous, although some of us like tend to feel like it becomes zen when you like are doing this process. But it is a very, very hard thing to do. Where do you find all these images? How do you make sure it's like the right data set or that it's the cleanest as possible, that sort of thing. So I find that these two things are like really what makes data sets really, really important to machine learning and machine learning art. And also I should say like where I started out, like in high school, I was doing a lot of like hip hop, like beat production. So I was using a lot of these machines, which are like, I sort of apply them as like the models of what we use now. And we were like, basically like this is when everyone was sampling stuff. So like people were sampling like beats and that sort of thing and then manipulating them and doing things with them. So like this feels like very connected to that world for me, which is like, how do you take most often other people's materials and make them feel like your own or make them feel like new, right? It's sort of that remix culture sort of thing, which I think is less talked about in the machine learning art world because so many people are more or less focused on realism. But I think there are analogies and ways to think about how do we take sampled works, but also make them feel like our own or like add different layers to them. So sort of from like a cultural perspective, I think it's a really interesting time to be working with machine learning art. So there's a couple of reasons also why I think like making your own data sets are really, really interesting. So if you have done anything in Runway, you know Runway is mostly built around pre-trained models. And it's cool for about a week or two of like playing around with like what's available in Runway. And then you're kind of like, cool, this is boring. Like lots of faces, lots of weird objects, that it's true. You very quickly run up against the limitations of pre-trained models, right? Because some data scientists at some lab decided, I want to make realistic faces. And as an artist, like realistic faces are cool up to a certain point, but then you're sort of like, I want to do more with this. I want to understand how to actually work with these things. So you quickly come to like, I need to train my own models, right? I need to train my own model on what I'm thinking about or what I want the machine to be thinking about, and then start to build up from that process, right? So another really great example of why you want to go and start building your own data sets. This is something that we will definitely be talking about more today, but like pre-made data sets are biased. And I think oftentimes nowadays when you say a data set is biased, people are like, that means it's racist, right? Or that means it's misogynist. And while that is very true in many cases, I actually think the thing about bias as just like a general rule of thumb about any data set is really helpful to think about. Meaning even the data sets you will be making in this class are very likely biased in one way or another. And part of that's just because we as humans we're the ones that make data sets, right? Even if you're doing some crazy complicated scripting setup and are like pulling down millions of images, at some point you made the decision of what to scrape, or you made the decision of where to look and go find things. So bias is not inherently negative, especially in many of the cases of with us and artists, and we want to work with smaller data sets that have a very like narrow scope. Like that's biased, but it's easier if you can make it apparent up front that like, hey, I think this thing is biased, or hey, I think this thing is only really meant to do this small activity, and anything larger than that is going to be problematic in many different ways, and here's what I think about it. So I want us to be clear that like many times bias is bad, but also bias can be good. But we should think about that, and we should be clear about what that bias is. So additionally, many training data sets, the most popular ones you will hear about, are made to be particularly very broad, right? So a lot of data sets are meant for object detection, meaning they need thousands upon thousands of objects. And often they like ignore minority considerations, right? So one thing that I've been really excited about is, and it's not even necessarily minority, right? It's like, if you think about machine learning models, many of them are made for English, right? But the structures of non-English languages can be very different. So all these things I think are worth considering as you build your own data sets, right? Am I creating a data set that is only for me, or will other people get access to it? And what happens when other people get access to it and use it? Are they going to find inherent biases in it? And how do I work around that, or how do I make that clear that this is the case? Many of the image data sets you will find have very funny histories. Many of them are built around celebrities. And the reason they're built around celebrities is that there are many legal loopholes that if you're a celebrity, you can't like consider your image or your face copyrighted. So lots of people have done stuff with celebrities. And so for instance, there's an example, or there's a data set called Celeb A. And Celeb A was made in like the 2000s, like the early 2000s. So it happens to have a lot of photos of George Bush in it, because George Bush was the American president at that time. And there were lots of photos of him, and he can't claim copyright on his own photographs because he's a very famous person. So again, lots of weird histories in these things. A lot of people are scraping from Creative Commons, which is good, but has its own limits as well. With that in mind, pretty much every training data set you'll see is photograph based, meaning they are biased toward photographs, right? But if you're an artist, you know that photographs are just one type of image. So we'll look at some data sets that are more art-based, but art-based data sets also come with their own biases, right? Is it all Western artists? Is it all artists with realistic style paintings, like those sort of things? Many of these data sets are also for business purposes. The reason we have many face data sets is for facial recognition. And I don't know what you think about facial recognition, but it's a problematic field. So we have to think about like, what was the purpose of this data set? And why would I be using it? Why should I be using faces in the future? What does that mean? Or what happens if someone else gets access to that? Self-driving cars are also a really popular one. Many of the pix-to-pix models you'll see are actually exist to train self-driving cars. So there again, it's like, what is this going to do? What do I want this thing to do, and how are people going to use it or not? So be aware about it. And lastly, I'll point out like many of them are very small resolutions. So you'll see a lot of 256 by 256 data sets out in the world. And that works because for most computers, that's fine. But for us as artists, like we want to print things, we want to see things at large scale. And a lot of times pre-existing data sets are not available to us in that case. So that's to say all of what this class is going to be like, maybe doing the opposite, or maybe like doubling down on some of these things to make it more apparent and clearer. Most pre-trained models were meant to cover a very small set of use cases. So pretty much everyone in the visual computer vision world works off a couple data sets. They work off of COCO, ImageNet, FFHQ, these like very small, very narrow, but they all work off the exact same model or the exact same data sets, meaning we don't really know what happens when many of these models are exposed to new data sets. So in the case of StyleGAN, which is the one that I'm particularly familiar with, like for a long time, if you threw artwork at the StyleGAN model, like no one had really gone and done the investigative research to understand how do we train a model better suited for artwork or non-photographic representations. And only maybe a month or two ago, NVIDIA, the people that made the StyleGAN model, also did a example of it using MET portraits. Now, these are still very realistic, right? So like they're not that far away from faces, but they're slightly different enough, and they learned some new techniques to work with these artistic images. They also figured out how to work with much smaller training data sets, right? So they were used to 150,000 images of photographic faces, and all of a sudden they were tasked with, how do we solve for 1,400 paintings? And they figured out ways to do this. So all this is saying, and I've said this before, but I want it to be clear, like, congrats, you're now a data scientist and machine learning researcher. Like, you are doing work that no one else has done before. And you're gonna learn things in this class, or like, we're gonna learn things in this class that like other people haven't gotten to yet. And maybe there are some people out there that can help us. But I'll say is like, if you struggle, that's okay. This is a very challenging thing to be a part of. And like, there aren't that many people out there doing what you're doing. So just be aware of that. But I think you can start calling yourself like a hobby ML researcher, and that's totally fine. And lastly, before we can all go on break, data sets are also just really bad. Like this is a literal image that exists in the TensorFlow flowers dataset. This has been tagged as a sunflower. And this is pretty clearly neither a realistic sunflower or like really representative sunflowers. And this is on the TensorFlow public dataset site. So be aware that like also we will be learning how to make better data sets than most major companies or research labs have. So, you know, congrats, you're both a machine learning researcher and probably better at them than many of their own jobs, right? It's a caveat, like that's not really true, but like, again, like this is what's currently acceptable in the world, and I think we can all agree that this could be better. So I want everyone to go on break feeling very empowered, maybe a little bit challenged, but like feel good about yourself, that you're gonna be making some really cool stuff in the next couple weeks. So with that, let's take a break. Let's do 5 minutes. So everyone come back at 8 o'clock. We might run a little over time. I know it's late for people in Europe, so if you do need to leave right at 1:30 your time, please feel free, and we'll have a little bit of extra at the end of class, and we'll record if you need to catch up later. Cool, so let's see everybody in 5 minutes. So that's 8 o'clock here in New York, but whatever at the hour is for you. Before I jump into models, are there any questions? All right, jump right in. Cool, so really quick, I just want to give you an overview of the type of models that we'll be building data sets for. There's no requirement to build for any of these particular models if you're just interested in like creating data sets, but if you are interested, like these are models that we generally have video recordings of, so if you are interested in training on these, you can. So we're going to talk a little bit about just sort of like what the requirements are for each of these data sets as well, or each of these models in terms of data sets as well. So we'll talk a little bit about style transfer, which is pretty straightforward. You just require 2 images. Next screen prediction, which Leah has shown an example of, which requires a single video. Then we'll talk about some Munit and Pix2Pix, which are image translation models. And those are generally like probably the first real example of the need to require a decent sized data set. And you need pairs of those. So basically like, if you see me talk about horses to zebras, horses to zebra is basically like a data set of horses and a data set of zebras, and being able to convert from one to the other. And then we'll talk about StyleGAN. So StyleGAN is probably the one that we'll mostly focus on in this class, just in terms of like how I'll be focusing on scale, because you do need a lot of images. You can get down to 500 images, but you'll generally have some issues in terms of just like image quality and that sort of thing. So in general, I'm going to assume that we're looking at data sets of like thousands or more images. So we'll quickly run through these. So if you haven't taken a class with me before, like the way that I mostly describe current machine learning state is that every one of these machine learning models has one specific thing that it does really well. And you have to sort of understand what that thing is in order to understand how to build a data set for it. So in style transfer, the idea is that it applies the style or the texture from one image to the content or like structure of another image. And if you're interested, here are links to GitHub repos and relevant papers. I'll also add some links to our class site for videos for each of these if you're interested in seeing how people make them. So its input for this are, you have two images for an input. So one is the content image, there's again the structure, and another is the style or the texture. And together it outputs one image of those two things combined. And this can do video, although the video is a little bit more of a time-intensive process, but it is possible to generate a style transfer video. These are like the famous examples, which is like taking a starry night and being able to apply it to a photograph of either a lion or something. And you'll see that it picks up some of the color, some of the texture. This is not my favorite example of a style transfer model, but this is sort of what happens. I think we've gotten to a place where it's much better in terms of like the stylistic quality, but you can still see a little bit here of how this works. And you can do video with this. Video involves a process of creating an optical flow model in order to create masks, but you can do a style transfer video. So dataset needs for this, pretty straightforward. All of us could do this without needing to require tools or anything. You just need a style image and a content image. So Pix2Pix. Pix2Pix is what's called an image translation model. What's helpful to know about Pix2Pix is that the images have to basically represent the same structure. So you can almost imagine them like they're onions skinned over top of each other, right? So the way people make Pix2Pix, and this is a funny version of, I believe, I forget, I'm blanking on the name of this, but it's like edges to cats. So this is edges to cats. So you draw a funny face or a funny picture of a cat and you get a cat with texture. Now the way this was trained is they actually took photos of cats and then they drew the outlines of the cats in order to get the structure or the outlines of an animal. And then once they've got that, then you can go ahead and do the reverse. So a common technique you'll see with Pix2Pix is that you generate one data set, and from that data set, you generate some translated method, whether it's edges, whether it's segments, which is like color blocking, or maybe you happen to have like a video camera that records two of the exact same scenes. So you can think about like a highway camera that could see a road both at daytime and nighttime, and then you can convert between them. So it generalizes the correlation between two images, which is a fancy way of saying it figures out how to translate from one of the images to the other. And the training data for this is basically a folder of two images. So you need a folder which is generally called A, the A data set, and then you need a folder of directly correlated images that is the B. So again, this is an example of image segmentation. So taking a building data set and having a poor data science intern probably go ahead and like
I think Derek's frozen. Yeah. I'm gonna drop that a message for him in Slack. Yeah, let's wait wait a little bit, but if he's not back in a bit, I can start up. Okay, I'll just pick up until Derek comes back. Um, yeah, so Pix2Pix is this model where you basically have like these paired images. So you need to have like this building and then also the segmented version of the building, which are these like colorful blocks that say like this is a door, this is a window, or this is like the edifice of this building. So the input to a Pix2Pix model is you take one image, like maybe a photo, and then it outputs the corresponding image. So it might output the segmentation of it. So you input this and it spits out this, or the reverse. So once you have this model trained, it can translate like A to B or B to A. So once you have, so you could input a segmentation image and then it will output this like photorealistic building thing.
Hey, sorry, I'm back
Hey.
if you want me to pick up from here.
Yeah, go ahead.
Okay, cool. Sorry about that. As you'll see, it happens. My internet does drop. Cool. So here's a quick example of just sort of make sure I can see everybody here. Cool. You can see my screen, right?
Mm-hmm.
Okay, great. So here's an example. I believe this is Gene Kogan's work. I could be wrong, but basically this is a Google satellite map of, so they basically have mapped segments of buildings in red, white being, I guess, grass or other, and then blue being sea. So they take this mapping and then you can do fun stuff like draw weird things in those colors, and it will sort of map as best it can to what you've given it as shapes. So again, this can be used in a very literal way. Training a machine learning model like self-driving cars, or it can be used in sort of a fun way like this. Next screen prediction. So next screen prediction works on a video. I'm going to skip playing with that video, but it's actually a special version of Pix2Pix. What it actually does, instead of saying the correlation is like an onion skin segment map, it actually takes a video segment or video sequence and takes the frames and says, A frame is frame 0, B frame is frame 1. So you break a video down into frames. This is an example of like a rocket, or I guess a firework. And you'll see like, so there's very, very subtle differences in all these pairs. But the idea here is that the model should then learn how to change a video from like, you give it a single frame of video and it should be able to produce the entire frame from there. We find out that it is very, very bad at that, and it produces fun, weird textures. But that's the idea. So basically the input, once it's been trained, is a single video frame, and the output is a sequence of videos with frames where basically you get the first frame, it produces a frame from that, then it takes that frame and it produces another frame from there. So it's sort of almost like a feedback model. Cyclogan and Munit, you'll hear me talk about these two interchangeably because they're pretty similar. The idea here is that Cyclogan is sort of like Pix2Pix, but it's weirder. It takes unpaired images and generalizes their translations. So whereas the Pix2Pix model is sort of like onion skinned over top of each other, Cyclogan or Munit does stuff that like takes things that might not be very well related and tries to relate them. So this is an example of the data set. These are the images actually in the horses and zebras model. So these are photos of our horses. These are photos of our zebras. You'll see again, we have a very weird image for one of our zebra images, but it does still work somehow. And when you train it, you're able to, we don't have an example here. There's a famous horse to zebra video that I can link to if you're interested. But it basically can translate horses to zebras and zebras back to horses. And it does that in a very complicated way that's probably too much for this period, for this class, but this is an example of where you can generate two really distinct different data sets and have them still sort of train to each other. So here again, like Pix2Pix, it takes a folder of images A, and it takes a folder of uncorrelated images B, and it tries to correlate them. And then similar to what you can do with Pix2Pix, you can go A to B, so you go horse to zebra, or you could also go zebra to horse. And the output for this is where the two models differ. Cyclogan will always produce the exact same image. So if you always give it a horse, the zebra image will always, if you give it the same horse photo, you'll get the same zebra output. Whereas Munit can actually produce some slightly different models based on using some injected noise. So Munit can produce multiple outputs, which is why I generally recommend folks try that because it's a little bit more fun to play with. And this happens to be my very favorite, weirdest example of Cyclogan, which is faces to ramen. So it converts ramen to faces and then back to ramen, or faces to ramen back to faces. And this is actually an example of how this model works. It does this, if you're familiar with machine learning models, it checks the loss between this and this. So it's actually like not interested in figuring out the loss of this image. It actually is just trying to figure out the, it's like, if you've ever tried to translate like English to Spanish and back to English and it always gets a little bit distorted, that's sort of how this model works. And lastly, StyleGAN. This is probably the one that most of you are at least familiar with or excited about. StyleGAN produces images of a unique singular data set. So this is an example of us doing a latent walk of one of my floral data sets. So unlike Pix2Pix or CycleGAN where it's doing a translation, this is basically generalizing all of the data within a single folder of images and trying to produce new but similar images. So in this case, it will produce something like the similar that you've given it, but it will hopefully sort of mash them up, right? So in the case of faces, if you're feeding it all blonde-haired photos, it will produce more blonde hair photos, but it should give you blue eyes, green eyes, brown eyes, people with beards, people with not beards, those sort of things. The trained data for this one is a lot of images, which is probably why you're all here. We need to produce a lot of images for these models, usually at the minimum 500, but realistically more likely 1,000. And these are examples of images that actually came from the data set that FHQ is trained on. This is another great example of where like, I don't think these are the best photos, but they still produce like fairly decent results. So these are clearly like somewhat poorly lit. One thing you should notice with this StyleGAN, and we'll talk about this a little bit more, is the reason that StyleGAN looks so good is all of the eyes are perfectly aligned. So if you draw a line through these images, you'll see the eyes are always in the same place. And this is why when it does that morphing, it looks pretty realistic because the eyes are always stuck in the same place, and the rest of the face sort of moves around those eyes. So that's a technique we'll talk about a little bit more in the next couple of weeks. Is like, how do you do that alignment, which is very hard. But if you can do that alignment, you can then produce better images if you can align on a single point. So we'll talk a little bit more about that technique. But there's something to know about StyleGAN is like the images themselves fed to the data set are like kind of poorly done, right? Like a professional portrait photographer would probably have a far better data set for us. But for whatever reason, NVIDIA didn't reach out to them. They just scraped Flickr. So the input for StyleGAN, and this is, if you've never taken any StyleGAN videos, this might be a little bit confusing, but it's actually a 512 dimensional array, which we feed as a vector. I've got a bunch of videos on this if you're interested. Leah and I have done many courses around vectors and that sort of thing. So if you're interested in this technique, we'll talk about this a little bit more. But basically, it trains a model to think purely as a mathematical space. And then if you provide it a point in that mathematical space, it can produce an image from that. Cool. So any questions about these models?
I have a question about next frame prediction. So you said that it takes the first frame of the video, right? So if, say like in the video, like I feel like fireworks it's always coming, it's usually come from like one point and then it goes up. But then if you have something crazier that's happening in the video, so it completely disregards what's happening past frame one. Or because I've been playing with it, like, I've been playing with it a lot the past couple of weeks. And it's really hard, like, you just can't predict what's going to happen, right? I'm like trying to produce typography and it's just not happening. But I don't know if it's because there's too much going on or if it's just because it just doesn't recognize it.
Often, I mean, the truth is just those models are pretty much chaotic feedback loops. So if you imagine what's been fed, what it's been trained on is a whole sequence of images. If a lot happens in that video, it's trying to generalize all that action into like a singular model. So the more that's good, the more that happens in your video, the more likely you are to get chaos in sort of the output. If you do really simple things like a zoom or a translation, if you train it long enough, we'll basically learn to like basically memorize that sequence and give you something back. But yes, they are very chaotic. And the thing to know is that it thinks in terms of image to next image. There are other models. There's a newer model called vid to vid that thinks of a sequence of frames. So it looks at the previous 3 frames and then generates a frame based on that. So you get a little bit more stability out of that. But yes, next frame prediction is like a super like chaotic model. You'll sometimes see it works really, really well, and then other times you'll see it works really, really poorly, and it can be a challenge to sort of work with. But yeah, actually, I can talk. Maybe next week I'll talk a little bit more about simple ways to like produce a really simple video for that works well with next frame prediction.
When you say train a lot, what's considered a lot for next frame prediction?
I can't really say because it kind of depends on how long your video is, as well as some other things. So I can cover a little bit of that more, maybe more next week. But I would say in general, the minimum that the default is it trains for 200 epochs. I would say more than likely you need to train it for like 400 epochs for it to like reproduce the same video, and that's if it's a very short, simple animation. So yeah. Any other questions? Cool. Leah, are you covering this or am I? I don't remember.
Up to you.
Okay, I'll do it. That's fine. Cool. So we're going to talk a little bit. We'll cover the Datasets tool library much more in the next couple weeks, but I wanted to talk about just like sort of the process of how this works. The video that Leah sent out over email sort of like walked you through installing this. So I definitely recommend if you haven't done that yet to go ahead and get your installation set up. Essentially the process for this is you install a thing called Anaconda, which helps control your environment. If you're on a Mac, you definitely need to do that. If you're on Windows, you might be able to get away without doing it. But I'd say if you're on a Mac, you definitely want to use Anaconda. And then you can install the Datasets tool library using Git. If you follow the commands in the video, that should get you set up. Dataset tools is a library that basically allows us to do what I would describe as the dataset normalization. It basically allows us to do filtering of an image dataset. It allows us to do cropping at scale. It allows us to do a bunch of techniques to basically try to wrangle a bunch of images into a similarly working data set. This is basically how it works. This is the really simple, straightforward version of it, which is that you open this up in a command line tool. You will run Python datasetstool.py, and then anything you see here that is a whatever, these are what we call arguments. So basically we're saying I have an input folder that is here, so you'll give it the path to your input folder. You'll then give it a path to where it should output the next images, and then you pass in a bunch of arguments. So in this case, we're saying like, hey, make the maximum size of this data set 1024 by 1024, and then you're gonna pass in a process type of square. I have a bunch of videos. We're gonna cover this way more in terms of like how to actually do this in the next couple weeks. But just know that this is the basic process. Is for everything, you're gonna run this command or a separate Python command, and then pass it a bunch of arguments. And those arguments are gonna help you sort of tell the machine how to manipulate these things to work best with your data set. So I wanna cover a really like high-level example of what I would do to generate a data set. This will be a data set of my favorite fluffy cat, Bone Bone. And this is basically like I use the Instagram scraper tool, which is also a demo of that we'll share, of scraped all of the images from Bone Bone's data set or Bone Bone's Instagram account, and then was able to produce a smaller data set from that data. So I'll just walk you through sort of how I would approach this. This is probably a very common process for most people. So as you think about over the next week or two, like what you're gonna build, think about how you can scrape a lot of data and then toss a bunch of it out to get like a unique data set of what you want to really get out of this. So in the case of, so here we'll go through the steps. The steps to do this are you need to scrape all these images, or maybe you generate your own, whatever it is. You need to basically make a big data set, a big folder of images. We're then going to use the Dataset Tools library to toss out all the images that are too small. We're then going to toss out all the duplicate images because in a lot of cases, if you're scraping data from a place, you will get a lot of duplicate images. Then you're going to do a hand curation step. And then the last step is sort of like, depending on the model you have, if you're going to go to StyleGAN, you want to crop it to squares. If you are going to use CycleGAN, you can sort of feed it whatever, and it'll do its own cropping inside the model. But we'll do a lot of like cropping, augmentation, that sort of thing. So this step 5, we're going to cover a lot more next week. But I'll just quickly walk us through the process. And then lastly, a human always should look at these things. Whether or not they do is a different story, but you should look at them and be able to sort of understand what's going on and be able to toss out some stuff just based on what you're seeing. Okay, so when I first scraped Instagram Scraper, I used this command called Instagram Scraper, and then I used the Instagram account is BoneBone29. I got thousands upon thousands of images of Bone Bone, which was awesome. And when I got them, let's see, oh, it says over here on the side how many I had. It says I had 2,444 images. Now, in some cases, there were videos in here, and I threw out the videos by just in Mac filtering by file type and then deleting all the MP4s. Dataset tools, I believe, will either ignore videos or might throw an error right now. It shouldn't, but it should just ignore them. But just be aware that you do want to make sure you just have images. So if you're going to, if you, for whatever reason, you want to include some video content, you'll want to convert those into static frames first. There's a video link to later in the section to show you how to do that if you're interested in it. But okay, so we've now got 2,444 items. I toss out the videos. That gives me some smaller subset. And then the next step is I want to, okay, so actually this is the how we run the Instagram scraper tool. And if I just sort of like dig around and look at some of the images, I'll see here that, I've got some images where there's like sort of this grid of images, which I'm going to want to toss out eventually. There's photos of, bone plus some human, which I'm not interested in the humans. So generally what I recommend is once you've scraped it, just sort of like look at a couple images and see if what you have is good or not. You'll generally just get a good sense of what you might need to be doing in the future. So the first thing I want to do is I want to remove all of the images that were smaller than 1024. That is done using this command. If you're interested in this, this uses the sort.py script. Now, not everyone needs to set the min size to 1024. I did this because I was going to train a StyleGAN model that was 1024 by 1024. But you can think about what resolution you want to train your models at. StyleGAN can take a 512 by 512 or a 256 by 256. It's kind of up to you. Now you also could work with smaller images and like up-res them or scale them up. That might introduce some blurriness into your data set, which might introduce blurriness into your model. All these things are just sort of like things you have to consider. I would generally recommend starting with the bare minimum that you need for the highest resolution that you want to work at. And then if like, so in this example, this cut me down to 1,130 images, which was still like within the realm of possibility. If this put me down to like 250 images, I might want to rethink my technique. And I might decide, well, do I want to train this at 512 by 512? Or do I want to like set my threshold a little bit lower, like say 724? And then I'll do some stuff either in Photoshop or in Dataset tools to actually scale up those images. So again, none of this is set in stone. It's all a little bit of like, what do I think is going to work here and what do I want to do? But when I ran this, I did get 1,130 images. I thought that was fine because I really just want to work with high-res bone photos. So now the next step would be, if I look around in there, I see that I've got some similar images. This is very common with Instagram where people will like screenshot their previous photo and repost it, or they just repost images just to keep engagement up, that sort of thing. So a lot of times you will need to run a command that is a deduping command. In that case, this is a thing that is called dedupe.py. And there's a couple of different techniques on how to use dedupe. There is like what we call just like an exact match. So it's basically if it's the exact same image, then you want to remove those duplicates. There's also a thing called relative matching, which is a lot of times, like I mentioned, people will screenshot an image and they will upload the same image, but it's been compressed just slightly because of a screenshot or because it was already uploaded to Instagram. So then we'll get a little bit more compressed again. Those will be seen by the machine as separate images. So there is a way to do some relative matching in here. I will let you know that relative matching is a very time-intensive process. It generally takes a couple hours to do that process to match everything. So again, this is where like time is kind of, flexible. You can run it overnight, whatever. So just be aware of that. I will mention, I shouldn't have mentioned this earlier. Dataset tools can be run on your machine, whether or not you have a fancy GPU or not. It runs all on the CPU. So you don't need to have like a complicated GPU or anything. Dataset tools will run on your Mac or your Windows without any additional techniques. So just be aware of that. Other things like when we get into training will require a GPU, which means you might need a Linux, you might need a Colab, you might need a server, those sort of things. But this can all run on your local machine. So pretty much anything we do in this class, except for the classification and object detection, won't require any heavy hardware. Okay, so we run our dedupe and it turns out we just had 2 duplicate images. Fine, no problem there. So as I then look, so basically what happens is after every one of these steps, I go through and I look at my images and I'm like, is this really ready to go? I don't look at every image, I just sort of like dig around and look at a couple of them. So here's a handful of images that I saw in this data set. And you'll see like I've got a paw. I really want mostly bone faces. So I might want to like, as I'm thinking about what I'm gonna eventually have to manually delete, I might want to manually delete this. Again, here's photos of bone with a big crowd. And then here's bone with a fake mustache, which I wasn't really interested in. So I'm still sort of like learning about like this data set and maybe needing to delete some things as I go through the process. So even after deduping, you might still have issues. These happen to be, if you were to like onion skin these photos, you would see that bone is just like slightly shifted. meaning that the dataset tools didn't find it as a duplicate. So you might still, like, even as you're going through these, you might actually want to delete things based on like them being the same image or whatnot. So just be aware of this. There's still often going to be a lot of manual hand curation that you have to do with these datasets. So at this point, you are generally doing a hand curation, and then so it might be deleting some of these images. It might be finding a duplicate or two of these and deleting them by hand. When I went through the hand deletion process, I ended up with about 1,035 images, which is right within the realm of like what I want to do for StyleGAN. So the last step is I know I need square images. And if you look here, I've got a bunch of rectangular images. So there are a lot of tools inside of dataset tools that are basically just about how to produce squares. Like this is actually like the most common thing that you're gonna have to figure out how to do is how to take a rectangle and turn it into a square. And we'll talk about this more next week because there's a lot of different ways you could do it. Some are better than others, and it mostly depends on what your data set is. So for example, in this thing, if I were to just say crop directly from the center, right? So like crop anything above or below and crop, like basically take the width as the minimum and then crop from the height, which is a pretty common technique. It's what Runway defaults to. If I look at these images, you'll see this one makes sense, right? I kept Bone in the frame. This one works well, even though it's cropping a little bit of Bone's ear, but then this one won't work well, right? This one will crop out Bone's eyes, which are pretty important to this model, right? I want like sort of a StyleGAN where it's sort of morphing around his face. So in this case, I have to change my technique, right? So there's a process type of crop to square, but there's also an argument for vertical alignment, right? So I get vertical alignment from the top, from the center, or from the bottom. And if I vertically align to the top, you'll see here, that keeps more of Bone's face in this. Now, is this gonna work for every image in this data set? Probably not. But what I might have to do is I might have to run it and then sort of see how bad it is. Or I might have to, you know, run it and hope for the best. This is the challenge is like, so I wanna look at every single 1,000 images and look at those and try to figure out if they work or not. This is where it takes a lot of time to sort of go through these things. Now there's also a technique of, let's say I wanted to keep the rectangle and I wanted to add space to the left or right of the image, right? That's another way that I could convert this to a square, right? And one technique you'll see pretty commonly with most people is they just add borders. They add a white border to the sides of the images and that converts it to a square. That will work, but in my experience, what you really want is you want more of that photographic detail, even if it's almost unusable, you want more of it in your data set. So a common technique that I will do is I will actually do a thing called reflection. And what reflection does is it actually reflects those images to both sides. Now, here's an example of what that image does. You'll see here on this one, it works okay, but the body gets a little weird. And in this case, again, we get a little bit of the ears sort of reflecting on each other. Now, if every one of my images in this data set did ear reflections, the model would learn to reflect ears. So it might not be a thing I want to do for every single image, but I could do it for images like this, or I could do it for when images are rectangular. So again, there's like no hard science to this stuff. It's all mostly just like, let's try it, see what happens, and sort of like maybe make adjustments here. Now I will also say that sometimes if you're really only 1,000 images, you just break down and you say, I'm gonna go through each image and I'm gonna open them in Photoshop and I'm gonna crop them as each image needs. That's totally valid and probably honestly the best way to do it. It's just how much time do you wanna spend? So just be aware that like for all of this, you're gonna run into issues. There are a lot of documentation inside the Datasets tool library. I will cover way more of this next week, but just so you know, it exists and it is there. And I'm going to have Leah do a little bit about dataset ethics.
Hey, and we're also at like the 1.5 hour mark. So if you need to like hop out because it's like 1:30 a.m., like by all means, go ahead and get some sleep. So yeah, I'm going to cover a little bit on dataset ethics because if you are scraping from people's Instagram accounts or like things on the internet, you should kind of be thinking about, the effects of doing so and the ways that, other people are affected by you compiling these big data sets. And these slides are sort of adapted from a guide that me and a former student are going to release in about a week. And so when that comes out, I'll also send that to you guys, but it's generally just how to be responsible while making AI artwork. Cool. And so there are 3 main ways to make data sets. like Esteban mentioned, you can make your own data set, meaning you use your own illustrations and photography or your own video that you've taken yourself. Second, you could scrape existing media, which I think the majority of you guys will probably be doing if you're scraping from like Flickr or Google Images. And the third way is you can use existing ready-made data sets like FFHQ or Celeb-A and things that are just like already out there made by someone else that you can just download as a big zip file. The first approach, making your own, it is sort of the safest approach when it comes to the question of like whose data is this, because it is all of your data. And the downside to this though is that it is labor intensive. Like Esteban mentioned, this is one of his works where he, I think Esteban, can you chime in? You use P5, I think, to make generative sketches and then you train it.
No, in this case, for the video that you have on your screen, I actually created everything in Adobe Illustrator, and then later on I use an app on iPad called PhotoDAP, and I mixed up all my vectors, and I generated hundreds of images. That was like the beginning of this, right? You know, like just experimenting with shapes in Illustrator. That's very, very early stage in my process. Later on, yes, I use some vectors or SVGs generated with the P5 videos, yes.
I see. Cool. Yeah, so I think like if you do make generative art, this might be like an easy, like if you have like, I don't know, algorithmic art that you have generated, this might be an avenue to which you can make your own data sets. If you are scraping existing media, which I think most of you will be doing, the least risky thing to do is to use media that's in the Creative Commons or in the public domain. So some examples of this are NASA. NASA has like this big gallery of images and video that are like free for the public to use for non-commercial purposes. And also the Biodiversity Heritage Library, which Derrick mentioned, is in the public domain because I think it's like more than 100 years old, or is old enough that it like nobody owns copyrights to it, and it is in the public domain for anybody to use. If you are not using like images that are in the public domain, you're using someone else's data. And yeah, that's literally what scraping existing media means. Someone has made something and you're using their data. So a particular example where this sort of went wrong was this person named Arfa. They scraped 55,000 artworks from a furry art forum. So this is a place where people who are in the furry community will go and sort of discover furry artists' work, and like they might have their own persona that they want like a particular avatar for, and like hire an artist and be like, hey, could you illustrate this for me? But yeah, Arfa went and scraped this website and trained a Stallion 2 model on it to generate these personas with a GAN, and put up this website where you can just go and see all of these generated personas and be like, I like this one, I'm going to download it. And this caused a lot of outrage within the furry community, especially the creators of the artwork, because they felt that this is sort of like a threat to their livelihood, and using their own artwork for this purpose, where someone can just like go and download one of these things, one of these personas for free without like sort of engaging in the community or like giving back, was sort of, yeah, they felt problematic. And one other thing is that if you are gathering like a data set, one thing to think about is the diversity of your training data, because if your diversity isn't high enough, then it's possible that your model may overfit, meaning that it might produce basically like what it has seen already in the training data. And this might be problematic if you are scraping like a particular artist's artwork and your model just produces that artist's artwork and then you're like, hey, I made this, even though it pretty much looks really similar to that original artist's artwork. So the flip side of this, Everest Pipkin, who's like a really, really awesome person, they have this quote as part of a talk that they gave on sort of the process of creating generative work from a body of data. And they said, to work with generative systems is to be a curator. To curate a corpus is to value the contributions inside of it. They are still artworks individually, and the people who make them are still artists. Curating your own corpora is to be able to deal with the original creators of your corpora as humans and as collaborators, not as data points. So yeah, just keep in mind that if you're scraping data, that this data is data that belongs to somebody, and this is someone who you're collaborating with to make your artwork, and it's not just like some anonymous person whose data I have free use of. So one thing that Everest did in a book of generated poems where they scraped all of the titles of posts from a particular forum called wordreference.com is like at the very end of the book, they just listed all the usernames of the people and just like spent like 3 pages saying thank you to everybody and provided an avenue for them to like opt out if they said, I don't want my posts in this data set. Yeah, to just like sort of be nice and take into consideration that these are real people's data that you're using. And the third method to compiling a data set is if you just come across a data set on the internet that's already made by someone else. So a couple questions to ask once if you come across a data set on the internet is to think about who made this data set and why did they make this? And think about like, how did this data come into this big zip file here? There is this pretty cool like project called Megapixels where I think 2 people, they're sort of detailing public biometric data sets that are like publicly available and uncovering how they were sourced, like where the data came from, what it's being used for. So a particular example is the Megaface dataset, which is a public dataset of 4.7 million faces. And so these faces were scraped by the University of Washington from Flickr users' photo albums without permission. So technically, like the albums are in the Creative Commons, but I think it's sort of misleading to the Flickr users because, yeah, I guess like when I upload photos to Flickr, I don't really think anybody's gonna go through and scrape all the faces from all of my photo albums to be used in a face recognition data set. And so this data set was publicly available and used by like companies like Amazon and Google and Tencent for developing facial recognition technology. And yeah, so yeah, if you come across data sets, just think critically about how they came to be and whether you should be using them and whether you support what causes they're being used for. One pretty important thing is if you're using a data set with people in them or you're using pictures of people, you have to be pretty careful and think about like how you would feel if like your own photo were in this data set. And if you don't really care about your own photo, like think about like if my mom's photo were in this data set and someone else, some anonymous person were compiling this big data set and my mom's photo were in it, like how would I feel? And if that makes you feel like a little weird, then maybe you should think twice and think like, can I ask for consent from the people whose faces I'm using or whose pictures I'm using? Or is there a way for them to say, if they see this, to come back to you and be like, I don't want to be in this data set, and for you to respect that and allow them to opt out of that. Another consideration when you have people in a data set, we mentioned biased data sets in the beginning. There's this case that happened in June, a couple months ago, of this model called Pulse, which the entire task of the model is to, given like an image that's super pixelated, to upscale it into like a non-pixelated image. So that model was probably trained on like a data set of faces that they then pixelated, and then the model tried to learn the translation between the pixelated image and the original high-res images. But yeah, as soon as this model was like released and people were like, this is cool, other people on the internet started playing with it, and they like, for example, input Obama very pixelated, and then the model just produces like this white man, because the original data set, the faces data set that this model was trained on, was not diverse enough in terms of like minority people. And so yeah, you should think about like the ways your data set might be skewed towards particular like stereotypes when it comes to like race or gender or other prevailing power structures that exist.
I should add with this model, there's some really interesting debates still going on whether or not it's a data set problem or a model problem. So there's a lot of people who said that actually this model overfit, and that's part of the problem, is that it overfits to white people. But regardless, I think, especially when working with faces or anything that is human, you should think a lot about your data set and how you actually want to go about producing it and working from it. So either way, I think oftentimes you'll also see a lot of people suggesting like this will work for everything. That is a big hot topic within AI, which is like this will work for any upres or whatever. And I think we should all be also very clear about like, what does this thing do? It is an experiment to see if we can do this, or like, we need more people to poke holes in this thing. So I think, again, to the case of like, no one should be expected to have a perfect model. You should make that clear up front as well. And I would also say like how you sell the model is also very important, or how you talk about it. Yeah, so this was a very complicated topic that many machine learning people had a lot to say about, and some people I think went way too aggressively to each side, and it should have been more of a discussion than it was an argument where people took a stand and like didn't even want to hear the other side about it. But yeah, it's a good example of like where people like took their own ideas and their own ethics and like just made them like, this is how everyone else thinks, right? And I think to Leah's point, like we should think about how other people think, because other people are going to be using these things. So yeah.
Yeah, and like adding on to that, all of these points I'm bringing up like are sort of unanswered questions, because this is a very, very new topic. And yeah, these are just sort of questions to sort of check in with yourself. But yeah, I'm not going to give you like strict answers of like, do this, don't do this, always do this. Yeah. In general, some best practices you can abide by is, yeah, sort of totally like you're definitely good, least risky is to use your own illustrations, photography, text, or video, like making your own data set. But if you are scraping work, it's best to prioritize work that's in the public domain, or if you're not, directly ask permission from those whose identity or work is in your data set. Or like, yeah, if that's not feasible, to like definitely thank them and give them an avenue to contact you if they want to opt out. And yeah, if you are posting the work of like your GAN online, make sure to tag people and thank them, and also phrase it like an experiment, like, hey, I scraped this person's, or yeah, this model was trained on data from this person, and you can tag them so that they know. And yeah, phrase it as like, I'm making this and playing with this, rather than like, I own this piece of work and it is mine. Yeah, and that's it for Dataset Ethics. Do you guys have any questions?
I have a very specific question that so I came across this one artwork, or it was like a product making thing. And so a couple of years ago, these two designers made a chair, like 4 prototype chairs, and they used StyleGAN to like generate these. I think their data set was really small, so they weren't like perfectly looking chairs, but you can kind of tell the shape of it. And then from there, I think they like kind of they based on the output, they made sketches and turned them into prototypes. Like, how is that okay? Or because they scraped 20th century chair designs. So, and I read that they were, I don't know if they actually did it, but they were like gonna actually make these chairs eventually, because what they did was like some scaled prototype things. So yeah, something like that. It's
Yeah, so
Yeah.
I think I would say that this is a world where like there's no, these are all gradients in like right and wrong. There's no like I think you could take the perspective that scraping any data is wrong, and like that would be a perspective. And if that's how you work in your own work, that's fine. Then there's like, I think to what Leah's saying, which is like there are less risky ways to work on this. From a legal perspective, I think we're also in like a very weird gray area where like, you know, there've been a lot of legal precedents around how much or a percentage does something have to change in order for it to be yours. You know, the law is really just about who has the most expensive lawyers these days. So like, I think there's just a bunch of different ways to think about it. I personally, like, my approach has been, if you make it in a way that feels different enough that I think it's okay, and like my version of okay is probably different than someone else's version of okay. Like, I think it's, again, I think to Leah's point, you should ask yourself those questions of like, is this too similar to so-and-so's work? If it is, then I should feel like I should probably like be like, that was a cool experiment, but I'm not going to do it. If you feel like it's producing something that is actually different, or like helped you think in a different way to produce something different, I personally see that as like, cool, that was a valuable exercise, right? Like all of us see images or videos or things out in the world every day and are often influenced by them. And sometimes we like don't think about how much we were influenced by them, and we end up like maybe making the same thing. Other times we realize like, oh, that was an influence, but I got to figure out how to make it my own. So again, like this is true of like non-machine learning artwork as well. And I think this is the challenge of just like, what is that threshold? And I think that threshold is going to be different for everyone. And there are legal thresholds that have to be met if you get sued or whatever. But oftentimes it's really just like, how do you as a human feel? And are you comfortable with it? Are you not? Do you think other people would be comfortable with it or not? So yeah, it's a very tricky. And this is like Leah said, like this is an emerging field, and like no one has clear answers about a lot of this stuff. And I'll also say like, so Daniel is asking also about like, particularly with StyleGAN, if you accumulate millions of images, but like you don't ask permission for them, is that okay? I mean, the truth is like most StyleGAN models are not producing realistic images out of them, right? Like I think the this furry does not exist is like a really good example of where like you could argue that those images are not the same as the image that was given, but it's a fine line, right? Like I think someone could go through there and find an image that looks very, very similar to what they have. You could say, well, is this the same or is it not? And it's such a challenge. My experience has just been like, if you go in and say like, this is an experiment, this is me trying things, like if you go in and say, I'm trying to avoid replicating this person's work, you will be given much more freedom to experiment and do that than you are if you say like, here's a thing I made. Oh, oops, it looks like someone else's, but hey, if you want to buy this, like, I'll sell this for $1,000, right? Like it just, so much of it is about how you approach things and how you talk about it. So it is a huge challenge, is a very like big gray area. And I think it will only become worse and not more clear as we go forward. So yeah, it's a challenge. I think like if you have questions about it, you're more than welcome to ask Leah and I, and Leah and I might not have the same perspective as well. So like, you know, at the end of the day, it really is about you and how, and what you feel comfortable producing.
Oh, Derek, you're muted.
Sorry, thank you. So your homework for this week is to start making data sets. And like, that's like throwing you in the deep end of the pool, I realize. So I wanna let you know that there are a number of resources of videos and tutorials already on my YouTube channel if you wanna take a look. So this is the playlist for pretty much anything dataset related. And I'll just sort of like, the playlist is never well categorized because YouTube makes it really hard to categorize things. But there are a couple journal videos. So the dataset walkthrough that I already did today is pretty much already up there in another format if you want to look at that. The video that Leah sent around in the very first email is this one. So if you haven't watched this one, I definitely recommend watching that. That will get you set up most of the way. There's a video here about splitting video into single frames. There is a whole category of scraping videos. So if you want to scrape off Flickr, Instagram, Pinterest, Behance, Tumblr, or Bing, videos already exist for those. The Google Images video that is up, you can watch it, but it will not work because Google broke their image API So you'll want to use Bing if you can't use Google, basically. I've got a couple other videos I want to produce between now and next week. So expect one around the YouTube download program, and then also Beautiful Soup, which we'll talk about in more detail next week. But just say this is all scraping that's available to you today if you want to do it. Here are a number of videos around using the Datasets tool library. So how to install it, how to do resizing and cropping, how to do some advanced cropping stuff, how to remove duplicates, and how to do sorting by size. I'll cover some of this in more detail next week, but I definitely recommend watching these videos ahead of time if you want to sort of get a little bit of a better understanding. So realistically, like for next week, I would just say like start finding images you think are good and maybe start thinking about where you can pull stuff from. My recommendation would be like maybe start with Instagram Scraper, find an account or a hashtag you like and start from scraping from there. Part of what we'll talk about, and maybe this is a thing we can do over the next couple weeks, is like either during our open Q&A or open working sessions, you can come with a data set and say, here's where I'm starting, like how do I manipulate this stuff? And we can work one-on-one with you to improve it. Or if you are like, you know, just like, I want to make something in this area, maybe start researching where you can find images for those sort of things. So yeah, this is sort of like where we're throwing you in the deep end, but I trust that everyone can like get started with these tasks, even if it's just as much as just like grabbing a bunch of links to like either data sets you found on Flickr or image data sets, that sort of thing. So let's start there. And then Leah and I will figure out a time for our first working session. And then you can also come to those sessions with like ideas and we can help sort of walk you through them. Does that sound good? Is that right, Leah? It seems right. Cool.
Yeah.
So again, we are over time. This is it for class. So if you need to drop off, you're more than welcome to. I'll stick around for maybe 10 more minutes if people have questions. I try to keep our Q&A sessions for these classes pretty short because I know like it's already been an hour and a half class. So if you have questions, I recommend asking in Slack and we can go ahead and answer them there. But if you have immediate questions, we can also talk about them now. So with that, thanks everybody. And I will stick around for like 5-10 minutes if people have questions.
I have one question, sorry.
Yeah, go for it.
We will see like some tools that help us understand the structure of our data sets, because I guess like at some point we'll start scraping a lot and we don't know what's going on anymore. So like something that gives us an overview would be super helpful.
Yeah, that's a really challenging topic, but I definitely have something in mind for how to start with that. So actually, I think maybe we'll look at that. I was gonna maybe say that for week 3, but I might try to squeeze it in next week. Either way, I'll probably record a video for it between now and next week, so I can at least link people to it. But yes, that is one of the bigger challenges, just like, what do I have in my data set and how do I like put these in categories and that sort of thing. There are no easy ways to do it. And I would say like, there are some ways to do it if you are working within a certain realm of tools that people already have, right? So the COCO data set is around different objects. So if you have a bunch of objects and you just want to say like, is this a cell phone or is it a water bottle? We can do that. When you start getting into these gray areas of like, is this a surrealist painting or a realistic painting or like a pointillism painting, like that will get harder because a lot of models for these things don't exist. And we can sort of work with maybe how we would go about doing that. We might have to train our own classifier, but it's also like, not sure it's even going to work. Like this is sort of the problem is like some of these things just might straight up might not work, and we'll have to see if what we can and cannot get away with. But yeah, that's a really hard challenge and one that I think lots of people struggle with. And there are some okay existing tools, but they're not always going to work for every use case.
I have a question. Are we going to discuss at some point how to optimize the use of a data set or the creation of a data set? But as you know, sometimes I create a 1,000 images data set, but sometimes it doesn't work when I'm training it because images are similar or maybe the colors are similar or things like that. Are we going to discuss that? I know that we are not going to discuss how to train it, but it would be helpful to know your feedback around optimizing the data set.
Yeah, so similar to Rafael's question, that's kind of a challenge. I've actually started asking some folks that I know if they have any tools to do that. I think we'll look at some ways in which to do something like it. And it might get us in a better direction, it might not, especially with your images because they are so abstract. A lot of the tools are not really built to sort of support that, but we can start to take a look at them. And I think part of what I want to figure out for this class is like, what are people interested in? And like, can I find some resources to help us with that? So there again, it might be something that I might not cover specifically like in like a lecture, but I could maybe like show some demos of some tools and you could sort of play with them and see if they work for you. Because yeah, it's also particularly with StyleGAN, and we'll talk about this more when we get to this to the StyleGAN class, but like it is also a challenge of like just sort of trying to optimize those things because GANs in particular are also kind of messy and noisy. So there are tools to get better results, and there's that. Have you played with that new StyleGAN model, the augmentations one yet?
Which one?
It's the one I recorded a video for maybe a month ago, and it's called augmentations.
I don't think so.
Okay, I'll send you a link to that because that might also help for you. There's other challenges of GANs that are like overfitting on the discriminator, and this one sort of helps with that. So I'll show an example of that. And if you're going to be in my StyleGAN class, we'll also we'll use that model as the base since that is sort of like the newest version to use. So it'll definitely help with certain things. But yes, all these are challenges, and I'm definitely down to like try to find some new tools to help people. But we might not find all the solutions immediately, which is true of like everyone. Like there are big research labs trying to solve these problems as well. So like I said, we're all going to be hobby researchers for the next couple weeks. And we might get there, we might not, but we'll find lots of cool things to play with in the meantime.
One more thing, your explanation also applies to a number of images that we are going to use, regardless or they are abstract or images or whatever. Are we going to discuss that?
Yeah, I mean, I think we'll definitely, when we get to object detection and clustering, which I probably start to cover clustering next week because I think it'll be a helpful topic. But we'll get to those things. And some of them will work better for abstract images than they will for non-abstract images. Other ones won't work. Again, especially within the world of abstract art, like many people have not built any tools yet for this. We'll really be trying things and seeing what sticks and what doesn't. But I'll definitely have some tools that we can try and play with and see how they work for you. I should have also mentioned, within StyleGAN, there is a version of the model that works with what we call class labels. So basically, if you have different types of buildings, like what the example that I'm going to do for our StyleGAN class is, I'm actually going to take all of the 5 or 6 like famous Instagram cats that I follow, and I'm actually going to build a GAN using each of those cats. But we're going to put them in class labels, so it'll be one model that can produce all 5 cats. Whereas if you try to do it separately, you would get sort of like a cat soup maybe. So we'll look at some examples of that. But basically, like one of the example demos that I'm going to do in week 3 is actually generating a object detection model to generate those classes. So basically, if you label a little bit of data and apply it to a big set of data, you can get big categories. So we'll look at some stuff like that. That might start to like move in the direction of what we want to be doing for a lot of these things. And that might work for abstract stuff. Let's try it and see what happens. But yeah, so we're going to look at maybe some classification systems to see if we can build better data sets using classification models, which is new for me because I've definitely not done a lot of stuff with classification before. And Leah will probably have a lot of thoughts or ideas on that from her previous work. Cool. Any other questions?
Yeah, just a quick follow-up. The clustering techniques you were mentioning, would they be based on some sort of dimensionality reduction technique of sorts?
Yeah, exactly. Yeah, so we'll look at an image clustering that is going to use PCA as well as feature detection. The problem we're going to find with that is that it's going to mostly be texture clustering. So it doesn't do a good job of actually like finding structures. I actually did an example of this last night, and like it found all of the photos of a cat in a bathroom because it looked at the tile and it found tile and it started clustering by tile. So like this is what happens with a lot of these models, is that the way they cluster is not always the way we expect them to. So we'll take a look at this and we'll sort of find like, oh, these also suck. Do we need to build our own models? And then we will turn this into like a 6-month-long class of generating our own like training models. So yeah, so again, like this is all like we're brushing up against the edges of so much stuff. And there are some people that I know in the community who are like building tools like this that we can maybe leverage, but they guaranteed will not work for every one of our use cases, but we're going to see what we can do. All right, y'all. So this is a really great first week. I know we have a lot of stuff to cover over the next couple weeks. So please feel free, if you keep coming up with questions this week, drop them in Slack. Leah and I and other folks are happy to jump in and respond. But yeah, really excited to sort of see what everybody produces. And I have a lot of homework for myself as well to make some things for folks. So I'm going to jump off and start doing that. So I'll see everybody next week.
See you guys next week.